So today is our last lecture of Unit 4. So that does mean Unit 4 test is coming up this Wednesday, April 27th. So today we just have a few topics to wrap up. One that we started very quickly at the end of class on Friday. We'll wrap it up today, and then we need one last little topic to kind of go over, one that should be pretty easy for you. So we were talking on Friday about parallel and perpendicular lines. Let's go back just a little bit further than that to review. If we have an equation like y equals a negative 2/3 x plus 4, there are two pieces of information in that graph, and that's all we need to create the line. The first is a starting point called the y-intercept. And that y-intercept is where it crosses the y-axis. So that plus 4 means that from the origin we went up 1, 2, 3, 4. That is our starting point, or y-intercept. The second piece of information was the number that multiplies the x, and that is our slope. And that slope is a ratio of rise to run. So from that starting point, this is saying we rise. Remember, the negative always goes with the rise. So we rise a -2, that means we go down 2, and we run 3. The run is always left to right. So 1, 2, 3. And that gives us a second point that's on that line. And our line then can be drawn through those 2 points. If we are looking to construct a line just from basic information, all we need to know is the slope and that y-intercept. If I ask you to find the equation of a line, with slope of 1/4 and y-intercept of -2, well, there's really not a whole lot to do there. It is simply y equals mx plus b, where m is the slope and b is the y-intercept. So we just replace the m with the slope of 1/4. So y equals 1/4 x, and we replace the b with the y-intercept of -2. So instead of plus b, we put in -2. So y equals 1/4 x minus 2. Not a whole lot for us to do there. More often than not, the starting point that we are given to construct these equations is not the y-intercept. It's just a random point that's going to be on the line. So we might be asked to find the equation for a line. I'm not going to write that part for the sake of time, but let's see, we're told we have a slope of 3/4 and that the line goes through the point 2, 8. Now there's actually a little bit of work for us to do. So we still start out with that equation, that form y equals mx plus b. And we do immediately have the m, the slope. So we can put this as y equals, replacing the m with 3/4, we get 3/4 x plus b. But we still need to find the value of that y-intercept, the b. And that's where we used that point. It goes through the point 2, 8, so that means y is 8. That is the y-coordinate. When x is 2. So 8 equals 3/4. Instead of times x, we put in the 2. And now the only variable here is the b, the missing y-intercept. And we solved it for that. We combined the 3/4 times 2. 8 equals 1.5 plus b. And then we subtracted 1.5 to find b. We get 6 and 1/2 equals b. So that meant we could replace this equation up here, replace the b in this equation, I should say, y equals 3/4 x. Instead of plus b, it's plus 6.5. And we went one step further to just say, well, find the equation of a line through just to say it goes through the 2 points. 3, 7, and 9, 3. Well, this is really pretty much the same as that last question, because anytime we have 2 points, we know the slope. Remember, slope was that slope formula, m equals y2 minus y1 over x2 minus x1. So here, if I just label my points 1 and 2, doesn't matter which one's which, y2 is the y-coordinate of point 2, that's 3. Minus y1 is the y-coordinate of point 1, that would be 7. x2 is the x-coordinate of point 2, that's the 9. Minus x1 is the x-coordinate of point 1, that's our 3. And then we subtract. 3 minus 7 is a negative 4. 9 minus 3 is 6. Negative 4/3 will reduce to negative 4/6 reduces to a negative 2/3. So that is our slope. So now we can plug that into our equation. Y equals mx plus b. We know that m, the slope, is negative 2/3. And now to find b, we can use either one of those 2 points. I'm just going to use the first one here, the 3, 7. So that means we replace the y with the 7, equals negative 2/3, and we replace x with 3. So we combine negative 2/3 times 3 is just a negative 2. And to solve for b, we add the 2 to get rid of the negative 2. Get 9 equals b. So again, we came back up here and replaced b in that equation. So instead of y equals negative 2/3 x plus b, it's negative 2/3 x plus 9 instead of b. The next stage was to look at parallel and perpendicular lines. Find the equation of a line parallel to y equals negative 1/2 x plus 7 and through the point 4, 3. So here we have this equation given. The only piece of information we want from that equation is that right there, the slope. The slope equals negative 1/2. That's all we care about. We are looking for a line parallel, which means the slope stays the same. So it's going to be negative 1/2. So in our equation, form y equals mx plus b, we replace m with negative 1/2. So y equals negative 1/2 x plus b. And now, as we have been, we go back to this given point, and we put that in for x and y to solve for b. So the y value is the 3, equals negative 1/2 times the x value is the 4. And we solve. Negative 1/2 times 4 is a negative 2. So 3 equals negative 2 plus b, and we solve for b by adding 2. 3 plus 2 is 5 equals b. So once again, we come back up to that equation, replace b with 5. Y equals negative 1/2 x plus 5 is our equation. we might be asked, find the equation of a line perpendicular to y equals 2/3 x minus 4 and through the point 6, -5. So once again, we have this equation over here. And the only piece of information we care about is that, the slope. The slope equals 2/3. But we are looking at perpendicular. We want the equation of a line perpendicular. And remember, in the equation of the line perpendicular lines have opposite reciprocal slopes. So the opposite reciprocal of 2/3, opposite means if it's positive, it becomes negative. Reciprocal means we flip it over. So it's going to be a -3/2 is the slope of that perpendicular line. So for y equals mx plus b, we replace m, our slope, with -3/2. And now to find b, we go to that given point. 6, -5. We put the -5 in for y. -3/2 times, and for x, we put the 6 plus b. We combine -3/2 times 6 is actually a -9. So -5 equals -9 plus b. And we solve for b by adding the 9. So 4 equals b. So again, we come back up to this equation, and instead of y equals -3/2 x plus b, put in the 4. Y equals -3/2 x plus 4. A lot of other little things that we can do with our points on our graph and formulas. The big formula we've already seen is the slope formula, which is the y2 minus y1, x2 minus x1. And we saw that on the graph. If we have a point, I'm just going to call them x1, y1, and x2, y2. The rise is just the difference in the y coordinates, and the run is just the difference in the x coordinates. That's the horizontal difference. Well, those differences can be used to find other features of our lines as well. One of them is distance between points. So the distance between points, if I think of this line segment that's at a slope as being the hypotenuse of a triangle, the legs of that triangle, well, we have a vertical leg that is the rise, and a horizontal leg of that triangle that is the run. And of course, vertical and horizontal always make a right angle to each other, so the right angle of our right triangle is right there, between the rise and run. So the distance between points, the distance squared is equal to the rise squared plus the run squared. Now we can shorten that by square rooting both sides to get rid of the squared on our distance. So it ends up being just the distance is equal to the square root of the rise squared, the run squared. And we can switch that to being run squared plus rise squared. It doesn't matter which order we put those two numbers in there, as long as they're both in there. So if I'm given the points let's say we're going to find the distance between let's do 8, 1 and 3, negative 11. So to find the distance between those 2 points. Now I could further define this up here. The way it's typically defined in textbooks is that the distance is equal to the square root of x2 minus x1 squared, it's technically the run, plus y2 minus y1 squared, which is the rise. So for this example, I'll do my run is the difference in my x coordinates. So I call them 1 and 2. It'll be 3 minus 8 squared, plus my rise, difference in my y coordinates again. Y2 would be the negative 11 minus the 1. That'll be squared. And if I do this out, 3 minus negative 8 is a negative 5. Negative 11 minus 1 is a negative 12. Negative 5 squared. Now again, you got to be careful on your calculator. If you just punch negative 5 and hit x squared, it's going to try to tell you it's negative 25. You got to remember that when you square a number in your calculator, you have to put it in parentheses. So negative 5 squared is a positive 25. Negative 12 squared is a positive 144. We add those together. 25 and 144 is 169. And the square root of 169 is 13. So the distance between those 2 points is 13 units. Whatever the lattice coordinates of your graph are, the units are going to be used on that. I'm going to have you guys try one in your notes here quick. I'm assuming that many of you have had this formula before, but I'm going to write it down again just so you can see it. I want you to find the distance between the points negative 2, 7 and 6, 8. I'll give you a couple minutes and we'll go over that. So if I label those points 1 and 2, my distance will be the square root of x2, which is 6, minus x1, which is negative 2, squared, plus y2, which is 8, minus y1, which is 7, squared. This ends up being 8 squared plus 1 squared. 8 squared is 64, 1 squared is 1. The square root of 65 gives us 8.062, we'll round that. 8.062 units between those points. The final algebraic formula that's important to us is finding the midpoint. if you were to go on and take a calculus class, finding midpoint's very important. The midpoint for as average displacement and average movement and stuff like that is a big deal. And what we find is if I have 2 points on my graph, the segment that connects those 2 points, the midpoint of that segment has coordinates that correspond to the midpoint of the rise and the midpoint of the run. So if I find the midpoint of the rise, that'll give me the y coordinate. And the midpoint of the run will give me the x coordinate. Well, we said the run is just the difference in the x coordinates. So the midpoint of the run is the average of the x coordinates. So if I'm finding the midpoint, the x coordinate is x1 plus x2 divided by 2. And the y coordinate is the average of the y coordinates. y1 plus y2 divided by 2. So if we are asked to find the midpoint of 7, 4 and -1, -10, we find the average of the coordinates. So the x coordinate is the average of the x coordinates. So I got 7 and -1. 7 plus -1 over 2. 7 plus -1 is 6. 6 over 2 is 3. That is my x coordinate. My y coordinate then is the average of the y coordinates. So I've got 4 and -10. 4 plus -10 over 2. 4 plus -10 is a -6. -6 divided by 2 is a -3. That is my y coordinate. So the midpoint is at x equals 3 and y equals -3, giving me that ordered pair. I'm going to have to try one in your notes. Find the midpoint of -3, 5 and 1, 11. I'll give you a minute, then we'll go over that. So for the x coordinate, we'll average the x coordinates. We have -3 and 1. So -3 plus 1 over 2. -3 plus 1 is a -2. -2 divided by 2 is a -1, giving us our x coordinate. For the y coordinate, we average the y coordinate. So we have 5 and 11. So it's 5 plus 11 over 2. 5 plus 11 is 16. 16 over 2 is 8, giving us a midpoint of -1, 8. Before we do anything else with algebra, I want to move on to our last topic. We can come back and fill in some more blanks in the algebra if we need to. But our last topic I want to talk about is data graphs. Now, these are all graphs that you will have seen before. We've all seen bar graphs. We'll just take a brief look at how they're constructed and some things to watch out for. You may not recognize the name, but you've probably seen histograms. the difference between a histogram and a bar graph. A bar graph is categorical data. You have choices A, B, and C, and you have the bars on there for those choices. The histogram is numerical data. So the histogram has number ranges. It might be 0 to 4, 5 to 9, 10 to 14. And the bars, of course, go up to represent those frequencies. Big difference here, of course, is the fact that this is ranges of numbers or numbers in the histogram instead of categories. But you'll notice another big difference. Here, there's space or gaps between the bars. In the histogram, there's not. That is because in numerical data, there's a natural flow from one category to another. 5 comes after 4. 10 comes after 9. They are connected. So when we talk about statistics in the next unit, we'll talk a little bit about psychology of statistics. And there's a lot of psychology in statistics and presentation of data. One of those things is right here. We connect the bars here so that your mind gets that connection from one category to the next. 0 to 4 is followed by 5 to 9. There's a logical progression, a logical connection and flow. Whereas with categorical data, A, B, and C, they could technically have been put in any order. Now, since I used the letters A, B, and C, it was probably logical to put them in that order. But if it was colors like red, blue, and green, there's no logical order to put those in. So there is no logical connection from one to the next or flow. So the bars are separated to show that logical separation between the categories. The next type of graph is a line graph. And a line graph is used mostly to show change over time. And typically that line graph has some sort of time across the bottom axis. And let's look at a school year divided up whether you're on quarters or trimesters. If you're on quarters, it would be a 9-week quarter. And let's just show your grade average for the week. Let's go 20, 40, 60, 80, 100. Something we don't go over in the course anymore is scaling that axis. But here, since I had limited space, I needed to get up to 100. You see I numbered by 20s just to make it all fit. We don't do a lot of time anymore going over how do we construct the graphs or how do we scale axes and stuff like that, because now we have technology. Microsoft Excel is in almost every computer. If you have the Office package, you have Excel. And it makes these graphs so quick and so automatic that we don't really need to be able to make the graphs by hand anymore. But it is handy, it is useful to be able to scale an axis like that, to get it up to what maximum number is needed. So let's say in week 1 of the quarter, you had an average of 84. So put a dot there at 84. In week 2, you had an average of 98 that week. So put a dot there. Week 3, you had a test. You might have struggled with it. Let's say it was a 79. Week 4, you were at an 88. Week 5, 87. Week 6, 92. Week 7, say there's another exam. You might have struggled a little bit. Let's call that 76. Week 8, 83. Week 9, let's say you finish strong with a 98%. So we can connect those dots. Now, one mistake that is commonly made is people want to do this. They want to connect that back there. That's not true. Your grade was never a 0 in the course. That's not a real data point. Now, these line graphs, there's a couple of things they're very useful for. One is we can see when your grades were going up or down. We can see the positive slope. That's when your grade was on the increase. We can see the negative slope. That's when your grade was falling or on the decline. We can also, though, because of how steep the line is, see when it dropped the fastest. We can see at these 2 points, it dropped rather quickly. As we're going through things, we saw those were both exam weeks. So maybe this is showing you struggled with tests. The other thing you'll notice, though, if I needed to go back, now I said specific numbers when I put these points on here, but if I needed to go back to this one right here and ask, what score was that? What was your score in week 1 or your average in week 1? Well, we had said 88, but there's no way looking at this graph that you're going to get 88 out of that. One of the weaknesses of a graph is it's very, very difficult to see exact numbers. Unless you have a very small frequency, so maybe your frequency only goes up to 5, then you might get exact numbers off the graph. But here, when we're going from 0 to 100 as our possible values, it's very difficult, especially these points over here, try to trace those back and get what the exact value was. It's just not the graph, the power, the strength of a graph is to very quickly find largest, the values. Here we can fairly quickly find the highest point on the graph. What week was your best score was right there. Smallest values. Again, we could very quickly see that this is your lowest score on the graph there. And we can compare to. If we look up here, we can quickly see that, well, you did better in week 4 than you did in week 7. And in some types of graph, like the line graph, we can see when things are rising or falling. Like I said, the exact numbers, not so good with the graphs. That's what tables are for. We'll look at data tables in our unit 5 for statistics. The last type of graph is the one that's going to take the most amount of work, and that is a circle or a pie graph. There is technically a difference between a circle graph and a pie graph. Circle graphs are seldom actually used. It's typically a pie graph. A pie graph shows categorical data. Circle graph would show numerical data. We typically don't use a circle graph with the numerical data. So for a pie graph, again, we don't need to be able to construct them. We want to be able to read them. So I might have a graph here where we look at the color of the uniform that people wear. And let's say that 30% of them are wearing white. And let's do 45% are wearing black. And 25% are wearing some other color. If 300 people were surveyed, observed, however you want to look at it here, how many were wearing black? Well, here it's asking how many, not what percent. So 45% would not be a correct answer here. 45% is just a step to get to the correct answer. We have to use that 45%. And of course, if we recall back to Unit 2, 45% is 45 out of 100. We need to find out how many that is out of the total of 300 people that were observed. And so we cross multiply and divide. 45 times 300 divided by 100, giving us 135. So there were 135 people wearing black in this survey, this observation. So that's really all we need you to be able to do for this, to read those basic graphs. I know you guys have probably seen these since 4th grade, so I'm not going to spend a lot of time on them. The circle graphs, working with the percents, maybe some little more effort, but not a lot. So with that, I want to let you know, those are our topics. Make sure you review for the test for Wednesday. The one topic that people tend to struggle with the most is the variation. And that is that direct and inverse variation. So make sure you take a look at that and understand how to do those problems. Otherwise, it's going to be strictly, all the slope and intercept or plotting points to graph and what we've gone over with parallel perpendicular lines and those formulas. So not a horrible test coming up. Also, Unit 5. I know we haven't finished Unit 4, we have to take the test, but want to make a note on Unit 5. We only have about 2 weeks left. So Unit 5 actually ends up being exactly 2 weeks long. There are 5 lectures in Unit 5. And the Unit 5 test is going to end up being on Wednesday, May 11th. We technically do not have classes on Friday, May 13th, but for you guys, I will log in on May 13th and be available to you. So if you have any questions, I'll be here to answer them to help you finish up Test 5. Or if you're still working on any other corrections at that point, I will be here for you. With that, that's all I have for lecture today. Does anybody still have any questions off of the Unit 3 test corrections that they want me to go over?
I have questions on number 13.
Number 13, okay, I'm going to grab that one just a second. Okay, so a physician orders a single dose 50, so that's our order, 50 milligrams of methotrexate for a child who weighs, our patient is 50 pounds. Oops, hold on. Child is 40 kilograms. And a height of 125 centimeters. The recommended pediatric dose is 25 to 75 milligrams per meter squared per week. That is a wide range. The strength, the label is 25 milligrams per milliliter. So is this a safe dose? So let's take a peek. We're going to start off with the order. Actually, sorry, let's check that. We're doing a safe dose. So the order is 50 milligrams. Let's figure out what the milligrams needs to be. So our patient is 40 kilograms, 125 centimeters. Our recommendation is per meter squared, so we need to find a body surface area. And if it's in metric, it's height, 125 centimeters, times weight of 40 kilograms divided by 3,600, and then the square root. So, second square root, 125 times 40 divided by 3,600 gives us 1.18 square meters of body surface area. So that's what we're going to start off with to find our recommended dose. And to make sure, we typically will start with the max dose, which will be the 75 milligrams per meter squared. Canceling out meters squared. That's going to give us milligrams, which is what the doctor's orders were. I gave you a little extra information there with the label. So 1.18 times 75 is 88.5 milligrams. That is the maximum dose. The minimum then can be found using a titration. Take that 88.5 milligrams times, we use the 75 milligrams per meter squared to find the max dose. We're going to do the 25 milligrams per meter squared to find the minimum dose. 88.5 times 25 divided by 75 gives us 29.5 milligrams is our minimum dose. So the safe range there is 29.5 to 88.5 milligrams. That is per week. The doctor's order of 50 milligrams is in the middle of that. So yes, this is a safe dose. That one throws you off a little bit because you don't actually need the strength of the 25 milligrams per milliliter. Any others that you'd like me to go over?
26.
6, okay. The doctor orders 3.5 milligrams per meter squared per day of lidocaine for a patient weighing 137 pounds and 5'7", which is 67 inches tall. So we find the body surface area. So its height, 67 times weight of 137. But since those are in pounds and inches, it's over 3,131. Second square root, 67 times 137 divided by 3,131. We get 1.71 square body surface area. So 1.71 square meters times the recommendation of 3.5 milligrams per 1 square meter. So you just multiply that out. 1.71 times the 3.5 gives you 5.99. We got about a minute and a half. Any other quick ones? You good? Oops, go ahead. 15. Okay. And okay, so we have an order for amoxil 0.250 grams orally. If the supply is 100 milligrams per milliliter. How many milliliters? So we start off with our order here, 0.250 grams over 1. And the first thing we have to do, since this is in milligrams for our supply, we have to convert that. So this will be 1 gram is 1,000 milligrams. That cancels out the grams. And then we have 100 milligrams per 1 milliliter. So the milligrams cancel out. So on top, we've got 0.25 times 1,000 times 1 milliliter. That is 250 milliliters. What did I get wrong? Oh, per 5 milliliters, sorry. I wrote this down wrong. This is 100 milligrams per 5 milliliters. So that should be 5 milliliters. So when I multiply that out, it is 0.25 times 1,000 times 5 is 1,250 milliliters over 1 times 1 times 100 is 100. And if you divide that out, you got 12.5 milliliters.
You don't have to do anything with the 8 hours.
Nope, the 8 hours, there's no time given in the recommendation, so that's just 12.5 milliliters every 8 hours is all.
Okay.
Okay, well, that's our time for the day. So you guys have a great day, and hopefully we'll see you on Wednesday for the test on Wednesday. If you don't log in, that's fine, but I'll be here to answer questions if you do. Have a great day.